joining us. Okay, that's good. It's first time we coming for this meetup. That's awesome. We're so happy for you to come. Just going to do some quick housekeeping. Is this on?
Give me a second.
Okay. So we're just going to go through basic agenda for today. We have two amazing speakers, and we'll be talking about our mission for. Sorry, the lights really affecting me. So the major mission for our K8SUG is for learning, especially for Kubernetes. So we deal with helping the community, the Kubernetes community learn faster and be able to develop the certifications. So we have coupons, we have every aspect of what you need to be able to learn faster in K8 and also AI. So we have some volunteers and organizers. Our major sponsor is Microsoft. That's the one providing this venue for us today, and also WSO2, also Code Cloud and Parker. So these are the blueprints. We've been the organization started September 2012. I know most of us might have heard about this, but I'm just giving you some updates. Right. Currently, this month we're having talks all over several countries. So I'm just going to rush through this, and then especially the Kubernetes program. When you certify, when you get certified in all the Kubernetes certifications, there's the CKA, CKAD, CKS, and CKN, and C and KCSA. You get the Kubernetes Kubernetes title, and that gives you some swags. Currently, there's some we have some programs going on. That's coming on, and then we have coupons for them. So we have the container security workshop, and we have codes for that. Also, we have all these events coming up. If you need the codes for that, if you want to attend those codes, we are able to provide you with the vouchers for that to subsidize the cost for entering those programs. So we have the KubeCon Europe that's holding April 1st to 4th. The Google Next, Las Vegas, and also we're currently doing a program, a campaign to that gives community members vouchers for you to be able to do the exam. Oh, sorry. So we have some vouchers for some exams. If you are interested, we are the community is providing support for us to be able to, for you to be able to do those certifications. I can tell you, if you some aspect of things that you don't normally go through in your normal field, when you go through the exams, there are some aspects you're able to learn. So we encourage you to go through the exams as well. So yeah. So so if we have if you would like to sponsor us, we have the links for that. And also, if you want to get some, so we're doing a campaign for a free voucher for the exam for 2 lucky winners, 100% voucher for all the exams. So that is CKA, CKAD, and CKS. So if you are interested, the link is there. And also, if you're unable to get the link after the program, you can meet myself or Andrea to do that. So also, just to remind you, by the end of today's presentation by our speakers, we'll be having a quiz, and in that quiz we have vouchers, we have coupons for Code Cloud, and also for Microsoft M365 license. Without no further ado, I'm going to welcome our first speaker, which is Amila. I hope I got that right. All right, please, with a round of applause.
Speech. Okay. Good evening, everyone. Thanks, K8SUG, for giving me this opportunity. I'm Amila from WSO2. I'm the head of engineering, right? And so today WSO2 is sponsoring this event, but anyway, thanks for giving me this opportunity. So I'm going to talk about a bit of a, I would say, radical topic. That's about going platformless in the area in the era of building platforms. So I got to talk with some of you while we were having the refreshments. Um, uh, I got to know some of you are into the DevOps area, and some are into AI, machine learning, and all those. If you are currently working on building some sort of a platform, wait until I finish this, right? And if you are planning to do something like that, then you will see, okay, whether it's a good idea or not. All right. Um, so nowadays, all the companies, all the enterprises are software companies. They have to do some sort of software things. Basically, this thing is a bit of a distraction, right? Yeah. Yeah. So they have to provide unique digital experiences to their users in order to win the market. It could be a bank, it could be a education institute, it could be some travel or tourism organization. They all have to provide a better digital experience to win the market. Now, that means they have to develop the software. Sometimes they can buy some of them, but for some of these things, they have to develop the software. It is not an easy thing, right? Now, if you look at your left hand side, if you look at the left hand side of the screen, right? These are the problems you face when you are writing software. Now, if you are starting your first application, yes, no problem. You just uh, it could be a front end application where you have a front end and a back end and a database, right? You just code it, and then you find a place to deploy it, and then you are done. You are done with hosting it, but there are other problems associated with that one. But when your organization is growing, right, when you are developing more and more such software, then there are things like, okay, you are not using the code you can reuse. Even if you want to reuse the code, the engineers, they are unable to discover that code, and then you have problems in testing, and because of these, like the production iterations are slow. So that means even though you are you want to get something quickly to the market, there are a lot of roadblocks. And let's assume like you come across some of those problems and then you have finished writing your application, but then there are a lot of other things you have to think of, right? For example, you need a proper runtime architecture. You need to plan for a deployment architecture. You need a proper CI/CD pipeline. To do all these things, you need, DevOps engineers or the same people with the DevOps skills. You need multiple environments because you can't directly put something to production. There are smaller companies, sometimes they do that, but that's not the recommended way and that's not secure. We need to think about the security, and we need site reliability engineering, the SRE stuff. Managing configurations, you need to manage different versions when your application matures. Like, okay, you have one, let's say you have built an API. Now you want to do the next version of it, so you need to do the version management. And after you deploy things, you need to observe it for the performance or the errors and all those things, and then you need to see the analytics as well. Otherwise you don't know how successful your application is. So this is not a easy thing. You need to, if you are starting from the scratch, you need to come up with all of these things. Now, from our experience in WSO2 with working with our customers for more than 18 plus years, what we have seen is, now before that I have to say WSO2 is a middleware company, right? We have, we develop middleware products for API management, integration, and then identity and access management, and also an internal developer platform. Now, when we develop middleware, people get those middleware and they try to, set up their own platform. So what we have seen is they spend a lot of time, right? Like more than 3 years, and with sometimes more than 100 people, and spending like 60% of their digital transformation budget on building these platforms. Sometimes they're successful, sometimes they are not. So with the experience we have and what we have seen, we have come up with a bit of a reference architecture on an internal developer platform. Because like what now internal developer platform is, it's like the like AI being the very hot thing these days. Like IDP is the other hot thing. I think started becoming hot thing maybe about 2 years ago, right? So we have come up with a bit of a reference architecture. Now it has two sides. One is like, the left-hand side is the design time. Now, when we are designing our applications, now this is not for an organization which is developing like one or two applications, but when you have more, what we are recommending is to do a more of a domain-driven design. Right now, let's say if we take a company, we can think of the finance department, HR department, marketing, customer success, R&D, those sort of departments, right? So the applications they want can be grouped or categorized into a domains. So that's what we have in these domains. And then I talked about the reusability and the discoverability, right? So the APIs which are designed by one team or one department or one domain can be put into this internal marketplace where others can then search and discover and use. It's not only APIs, right? It could be data, databases, and events as well. Because like when we are doing integrations and when we are building these applications, we sometimes need to consume APIs, events, and data. Now, the left-hand side is on like, how you design that. But the challenge is now how we are going to deploy this in the real world. For that also, there's a deployment architecture which we have come up with. We call it the cell-based architecture. I'll get to that in a later slide. So what we are doing is like we are like setting up the margins, so the boundaries of one domain, and then we are like including the applications of that domain within that boundary, and then we are controlling the access through the API gateways and then the authentication and authorization engines. So the left-hand side has to be done by, the software, the application developers and the architects. And then the right-hand side has to be done by, the DevOps and SRE teams. Now, so I mentioned like this is an reference architecture for an internal developer platform. Now, these are like some of the important things you need to have. In the previous slide also, I mentioned that there are challenges like we need a CI/CD pipeline, we need a service catalog to discover the reusable components. We need to provision infrastructure. We need to manage infrastructure, and then we need to manage the cost as well, because like if you set up a platform and if you don't manage it, and after some time, you will get a huge bill if you don't control it. And then you need to monitor and observe, right? Okay, how many people are using this? How many times my APIs have been invoked? How many of them have been successful? How many of them are failures? Likewise. So all those things are there. And most importantly, regardless of how super or how secure, how performant the internal developer platform is, if it doesn't have a good developer experience, if it doesn't provide a good developer experience, your developers won't use it, or they won't adapt it, right? Then it will become a failure. We have sometimes seen the large enterprises, they set up these solutions and platforms, especially on API management. The huge platforms, but and they publish APIs as well, but there's no adaptation. So you need to have, especially when it comes to the internal developer platform, you need to have a good developer experience as well. Now, to do this, now we can't write every piece of code we want in an internal developer platform, right? Now, we need some cloud native middleware. Now, I would say like more than 90 or 95% of the times, people will go for a Kubernetes kind of a deployment due to obvious advantages. But Kubernetes is not only enough in this case, right? You need some cloud native middleware. Cloud native middleware means it's a one or more software, right, that provides some capabilities which are not provided by the underlying cloud infrastructure. So these middleware, they work with the cloud infrastructure, and it allows our applications to get these things done in a scalable, resilient, and maintainable manner. So that's what the cloud native middleware provides. Now, where can we find this cloud native middleware? So one of the most popular place is the cloud native, the CNCF landscape, right? It's very crowded. You see, like now I have tried to take all the things available in the CNCF landscape into a slide, but it's not even readable. There are so many things. So it's a challenge for you to find these things as well. So now if you are trying to, build something like this, so you have to go and like, okay, do your own research and find things and then master those, and so a lot of challenges. Right. Because of that, we have done a reference implementation of the reference architecture as well. It's a real implementation, not just a reference implementation, right? And in that implementation, we have used this middleware, the cloud native middleware from the CNCF, the landscape. So if you are in the DevOps or SRE, or even if you are software engineering, you will easily realize or identify some of these things, like I would say Argo, Harbor, the container registry, Helm for the container orchestration, and Envoy. What else? Kubernetes is obviously there, and Redis, Prometheus, and so we have used these things. I'll explain where we are using this and how we are using it. And this is the high-level architecture of the internal developer platform, the Choreo, which I mentioned, right? Now, let me take a step back, and just for the sake of completeness, I'll tell what normally the internal developer platforms does, right? So basically, what we want is to empower our developers to develop their software in a quick, secure manner. So here now this part of things, these are done by these are in the developers environment, right? So they have the IDEs, they have the GitHub repositories, GitHub or GitLab or whatever Git repositories. So they get the requirements, right? Then they write the code and they push it to the repository. Now, this code has to be taken by someone, right? I'm not just talking about Choreo at the moment or this internal developer platform. That code has to be taken by someone, build it, and build the artifacts which can be deployed. And they have to do the scanning, testing, and all those, and then deploy. Now, when deploying also, there are requirements of like, multiple environments. Like we need a dev, test, production kind of environments. And then we need to control access, those kind of things. So what Choreo does is, when the developers, when they commit the changes to the repositories, Choreo takes the code, build it, and then create the container images, and then deploy them in according to that reference architecture I mentioned. They deploy it in this data plane. So it has a control plane and a data plane. Both of them are running in Kubernetes clusters. So this data plane can run on any infrastructure. You can see Microsoft Azure, AWS, Google Cloud, VMware, can run on any infrastructure, right? So that is what it does. And then, of course, after that, like you can see the analytics and different dashboards as well. So to tell a little bit about, because now here also you can see these cells here, right? Now to tell a little bit about the cell-based architecture, it is a decentralized architecture which actually WSO2 came up with related to cloud native applications. It goes, hand in hand with the domain-driven design. In the domain-driven design, like a domain is equivalent to a cell in the cell-based architecture. It could be an entire domain can be one cell, or a part of the domain can be a cell. And what we do is we group these components within a certain domain into a network cell, right? There are network boundaries. There's no physical boundaries, but there are network boundaries which controls the access and manages the access using these gateways. So that is what the cell-based architecture does. Now, here, you see how we control this access, right? You see there's the north and southbound traffic, and then also we have east and westbound traffic. Now, basically the traffic coming from, the northbound traffic is the traffic coming from the external channels, like, the consumers. And then the southbound traffic is basically the request we are doing, making to the external services, like it could be Salesforce or some other other API like Shopify or something like that. And then we have the west and eastbound traffic, which are going to our own code, our other domains. For example, the finance domain, an application in the finance domain might want to talk to an application in the HR domain to get some information. So those are in two different cells. So we have to control that as well. So those are the east and westbound traffic. Now, following this architecture, right? Following that reference architecture I mentioned, and using the cloud native middleware, which I showed, we have come up with this sort of a implementation. Now, this is only the data plane of Choreo, right? Control plane also uses similar things. Now, I'll explain what we are doing, right? Or the major components. So here you can see my mouse point, right? Yeah. So we have external facing gateway, API gateway, and we have internal facing API gateway as well. So all the traffic coming from the outside has to go through this gateway. It does the authentication and authorization of these API calls. And this gateway, for the gateway, we are using WSO2 and Envoy products. After the authentication is done, basically, we are routing the request to the original service of that domain. Now, in this case, um, we have a concept called project as well. So, like, let's say the HR domains applications will be in the HR project, right? And then if there are internal traffic, right? Let's say now we have this is a S1 and S2 means like service 1 and service 2. If the service 2 wants to talk to a service in another domain, that is going through this internal gateway, right? And also there's a egress gateway as well. That means a gateway which is controlling the request going out. Now, this is actually a problem nowadays, especially with these AI APIs, LLMs, usage of LLMs, because like the companies, they want to control, okay, what are the APIs we are calling and how frequently and in what frequency we are calling them, because like these are huge costs. So such things, and not only the AI APIs, the things like, if you are talking to something like Salesforce kind of APIs also, like, you have to control them, because not everyone should be able to control. For example, especially in this sort of a domain-driven design, a project in the sales domain should only be able to talk to the Salesforce. And if anyone else want to consume that data, they have to come to that project and use that API. So that sort of, because of that, this sort of a egress gateway is also important. So those are the major things. And now there's this cell boundary. In the cell-based architecture, we have this cell boundary. And that is actually achieved using the Kubernetes namespaces. And we are also using the Kubernetes deployment services and config maps and secrets, all those things. These boundaries are handled by a namespace. So every project get their own namespace. If I go to the left-hand side, now, when the developers, when they commit their code, we have our whole build system using the Argo workflows. It will pick up the changes. It will build the code using the build packs as well. The build packs.io project. It can build by following a certain spec, and then it will build the Docker images and then do the scanning using Trivy, and then push it to the Docker registry, the container registry. We are using Harbor. And then our the data plane, there are some other agents which we haven't mentioned here. They will pick up these changes in the container registry, and they will deploy them in these, S1 and S2, and basically as the applications. So we are also using Cilium and eBPF a lot to control these L3 and L4 access. For example, like who can talk to which, like Kubernetes namespace alone won't be able to control those things. So we are using Cilium and eBPF, and we are using WireGuard to encrypt this communication going inside the namespace. So we have to, in Choreo now, we need to, like, when you have developed internal developer platform, like, just the developers will deploy their code in that, but they also need to troubleshoot, right? Like if something goes wrong, they don't know what's happening. So they need to see the logs. So we need to collect all the logs. So we are collecting all the container logs and Kubernetes events using FluentBit, and then storing them in OpenSearch. We used cloud services like Asia has something which I can't remember now, but the thing is, like, we wanted this to be cloud agnostic. We wanted this data plane to be cloud agnostic, because otherwise we are bound to one cloud provider. We want our users to deploy this data plane in any infrastructure they want. So we wanted it to be cloud agnostic, and so we have chosen all these projects which can be run on any infrastructure, depending on any of the cloud services for this data plane architecture. So that is about the logs. And then we are also collecting the analytics or the metrics, and we are storing them in Prometheus. And for backups and restoration, we are using Velero. We are using Redis in the gateways for some caching things, things like that. And one other thing is this this platform allows scale to zero, right? That means like if one of the applications, if they are not being used for a certain time, if they're idle for a certain time, we are scaling it to zero pods to save the cost. Otherwise, like when you keep deploying more and more applications, your cost will grow. So we are using KDA, another project in CNCF, to deploy to do the scale to zero. So these are the things which we have used, and this is how we have come up with this internal developer platforms data plane. Right. So now when you have something like this, it streamlines the development process, right? Like the developers, they can find what are the APIs they want to reuse. And another challenge is like we can't give the developers the credentials to production systems, right? Like say you are developing an application, first you want the dev credentials, but then when you want to push it to production, we can't give the production credentials to the developers. That has to be done by someone who has authority and access to the production. So that sort of config management, so all those things become seamless and streamlined. And then the productivity, you don't need to wait asking your platform engineering team or SRE team for resources. Okay, I want a database, I want this, and then they don't need to write any Kubernetes YAMLs to deploy things. They just need to write the code, and it will, like, within minutes it will get deployed. So this allows the businesses to speed up the things. They can go to market quickly. So now we have built a platform. Why did I say we are going platformless? Now this codeless, wireless, serverless. So we use these terms in different ways. Like codeless means yes, there's no code. That's and wireless means there's no wire, right? But to provide wireless, there are wires somewhere we don't see, right? Similarly, and then when you say serverless, it doesn't mean there are no servers. There are servers, but you don't see them and you don't deal with them. And even there are serverless databases, but that doesn't mean there's no server running. There's a server running, and you don't worry about it. Here also, by platformless, what we means is like, yes, there is a platform. Someone has built a platform for you. You don't need to do it. You don't need to touch it. You just have to work on top of that. So what we are telling is, okay, you have to go platformless in this era to deliver things quickly. So what's the role of a platform engineer in a platformless strategy? If a company is adopting a platformless strategy, what they are going to do with their platform engineers, right? Now that's why I said like wait until the end, because like otherwise if you are into platform engineering, you might have felt, okay, what this guy is telling, okay, going platformless and all those things, right? What happened to our jobs and all those. So for the larger tech companies, they have like a lot of different requirements, like we can't sometimes satisfy in a out of the box platform. So such companies, like due to compliance and all those policies and all those, it might make sense to use a large team and develop this sort of a platform. But for the small and medium scales, they have a lot of challenges, right? The cost is high, they need skills, and it takes time, and then that hinders your the delivery of the business applications. So for them, what we are telling is, okay, it's better to buy an internal developer platform rather than building it, and then use a small team to adapt it, right, based on your needs. So that's where the platform engineers come into play, right? Now if you remember, like you don't remember when I started in the industry, like about 15, 16 years ago when I started. Those days in the company I started working, there were these sysadmins. They used to buy, uh, hardware and had set up them in the server rooms. And when we wanted to deploy something, we had to ask for a VM from them. So their task was to, they install these virtualization software and all those, and like they were the kings. Like they control that, similar to the DBAs. Like they have their own kingdom kind of thing, similar like that. The sysadmins are also, they are different. Those days they were a different tribe. If you don't know, there's a sysadmin day as well. It's celebrated somewhere in the middle of the year, somewhere May or June, right? So they are that sort of a special tribe. But with the introduction of AWS and the cloud infrastructure, the infrastructure as service vendors, they had to change their way of things. The companies, like, they didn't want to manage data. What's the word? Server rooms and the hardware, and they just wanted to provision a VM in one of these infrastructures. Now then the sysadmins has to adapt their work, and like, okay, they were now provisioning these VMs, and they were automating things, and they were working on the other deployment architecture related things. And then came this Terraform, CloudFormation, those kind of things. So they started learning those, and they mastered, and then their work has shifted to that area. Similarly, for the platform engineers, like if a platform is already there, now they don't have to work on setting up platform, but they have to do some work to make it optimize, or make it ready to the organization requirements. For sometimes, like, we want to onboard certain things, like, okay, the databases, okay, we only allow let's say a PostgreSQL, and for the caching, we need some sort of a caching thing, and a message broker. So they'll have to onboard sometimes those kind of things, and then set up these projects and policies, and there are governance things. For example, like when you are on this sort of an environment, like, okay, people can create any application they want, but you need to do some governing as well. And so there are things which the platform engineers can do on top of this platform. So that is what the platform engineer's role will be on top of this sort of a platform. Yeah. So that's about going platformless in the era of building platforms. So if you want to talk about read more about these things, you have this set of links, some articles about platformless, cell-based architecture, blah blah blah. And then this implementation of Choreo, you can access it through that URL. You can actually give it a try. If you have a code which you have written, you should be able to deploy it in Choreo, and basically by just plugging your GitHub repository and doing some small things. That and yeah, that's it. That's all I wanted to cover. Yeah, do you have time, or I'm over time? Yeah, I can take 1 or 2 questions if you have. Yeah.
Particular platform architecture, how modular it is to replace or adapt to new components. Like it seems like it's more or less the microservice architecture.
Yeah.
But want to use some kind of monolith or some to bring a new
application
to that. So how it would be possible?
I would say you will have to bring it still within that. For example, like now your monolith application is in some domain, right? So what we are telling is, okay, that belongs to that domain, right? Let's say your monolith application is in the, let's say, HR domain. So what we are telling is, okay, create a project for the HR department, and you deploy that in within that project, right? And then you decide, okay, whether this needs access from the outside, or whether this needs access from the inside. But it will, even though it's a monolith, it will become a microservice inside this architecture. Yeah, yeah. I didn't get that. Hmm. Yeah. Yeah. Yeah, that's possible. Yeah, yeah. Yeah. Yeah.
So you said that you are using WireGuard for encrypted connection between two services. So what is the advantage over using an MPLS connection?
Yeah. So it's one thing is it's easy, right? For if we want to set up this MTLS and all those, then we have to use a service mesh as well, right? Because we have to change the certificates and all those. So instead of that, what we have done is using WireGuard to just encrypt the communication happening between the services. We sometimes back we used I think Linkerd, but then we thought, okay, that's an overkill for our requirement because we have Cilium as well, right? Cilium also covers some things like retries and these what is it, access control and all those things. So we have Cilium. So we got rid of Linkerd and we are using those two now.
One of my project development MPLS. I mean, we have built our own certificate service and we just replace certificates all the time. But let's say like it is little bit less overhead than, I mean, in my opinion, like we need to say it is less overhead than the WireGuard, because the WireGuard comes with a quite deep configuration. Like if something gone bad, like the private key or something else is not updated. I mean, I hope that it is created between each services, right?
Yes, I don't know the underneath implementation details. I'll have to check with the team, but maybe we can take it offline, no problem. You had a question?
I'm curious about does your architecture handle stateful applications, like if you wanted to say host a database or a custom stateful application within a cell?
Yeah.
As well as operational requirements, like when you generally have stateful application, to take down a node, you more have to deep mark that node as depreciated so it could offload work processes and then spawn new ones, you know, like the ability to scale up and down. Does it handle that?
Yeah.
Like operator SDK?
Yeah, so all you need is like a place to store that state, right? Whenever the container goes down and comes up, that state should be there. Deprecate. Oh.
Yes, you want to scale down.
Right.
That's the challenging, I see, architecture, ability to scale down from, you have 1,000 instances, now you want to go down to like 100.
Right.
But you want to, you know, like if your database like Cassandra, you want to rebalance.
Does it
do that? Does it
now, when we take something like Cassandra, it has its own complications, right? It's a bit of a complex thing. But now, if any of the things you are deploying, if it needs basically what we you can plug these volumes, right? And then like what you call the volume mounts, and then this will keep scaling without any problem, right? So everyone has the same state. And
yeah, but you can volume mounts. I'm more about descaling.
Yeah, so descaling
scaling is very easy sometimes,
right? Yeah,
but then trying to get smaller can be quite challenging because, for example, you have to mark a node as, I don't know, I've forgotten exact terminology, but hey, this node has been removed. Please,
nodes,
all your cars or petitions onto other nodes, and then you can.
We do it. We have to do it time to time, depending on some of the but I haven't seen any problems. Like for example, like we have to migrate things. When we sometimes like Kubernetes time to time come and tell, okay, now so we are using Asia Kubernetes service. It time to time comes and tell, okay, now you need to update this to this version, right? So we can't disrupt our users. So we have to start up these new nodes, and then what's the word? Yes, I can't remember the word. So basically, yeah, that doesn't come. So we have done those things, but it hasn't been a problem. But again, similar to the previous question, some of the underlying things, I mean, I'm not the best person to answer those, but if you ask me later, I could check with the team and get back.
Oh, yeah, I'm just curious how to handle it.
Yeah. One thing what I can tell is like all our internal applications, WSO2, all the internal applications are running in Korea. We have nearly 100 applications. We are now going to deploy Harbor. Harbor as application also in Korea for one of our internal cases. So that's a bit of a complex deployment because it needs a lot of storage. But I think we are going to use S3 for that one. But again, a bit of a distributed thing. So there we have been deploying complex things in this one. Sorry, yeah.
The question, what's the cost model?
The cost model is based on the number of applications or the components. So we call a application, we call it a component. So the cost model is currently based on the number of components, right? You get 5 components for free, and basically you can do your hobby things in this one. Yeah. And then since we are scaling things down when it is not being used, so
So it's like a pay-as-you-go.
it is. Yeah. Right. Thank you. I'll disconnect from the Zoom, right? I'm not there.